Yeah.
Yeah. Today I will talk about the hyperparameters tuning techniques and the the methods how to tune hyperparameters. So I will go through four main parts. The first are, the first part I will talk about uh, the definition of hyperparameters and then some basic optimization methods. And the third part we talk about specifically about the Bayesian optimization method. It is quite important in many hyperparameter optimization tools nowadays. And the final part will make a brief comparison of different um, libraries. So the hyperparameters is the parameters of a algorithm that we need to define it and assign it to a assign them a like fixed values before training, and they can be learned during the training process. Uh, mm, for the solutions performance, hyperparameter is a important key that affect the performance of your model or your algorithms. And when you choose the right hyperparameters, it will help you in, enhance predictive performance of the algorithm. And further, when you will do the ensemble, you know it can have your model more like more uh, better, because you know when you assemble the some tool model, um, it's it's pretty better than you haven't tuned any model and assemble them together. And hyperparameter usually hyperparameter is defined when you're training the model, but it can be used when you in when you when you at the when you at the inference phase. Like when training model, you use some hyperparameters like ASCII, number of nodes, learning rate, or something like that. And also it can be used in inference phase, like the confidence score of the model. It mainly depend on your data set. Like I have I did an experiment um, on the inference phase of our CPNet models. I use a optimization search method to find the optimal confidence score of our model to get the best result of bounding box. But when it was compared to the ground truth bounding box, I will talk it later, and you will have a clear intuition about it. And the main ingredients for a hyperparameter optimization procedure is you need a model whose parameters have to be defined, and a search space and for each hyperparameter you need a like a interval that the value it need to be inside it, and a cross validation scheme. Is this scheme have you have the the way to compute the loss function. The loss function or score function is the you can consider is the objective function that we maybe want minimize or maximize it. And finally, you need a method of searching and sampling the candidates, like uh, the combinations of hyperparameters. And my presentation mostly focus on this step. So there are many methods of optimization. Like the basic one is manual search, like your but like based on your knowledge and experience, you set a fixed value for your hyperparameters, and then you train the model, and then evaluate it based on the chosen hyperparameter, and then when you see some when you see when you think it can be better, then you trick the value of the hyperparameter and start over again. Mm, Overall, the overall intuition is you exploring smaller and smaller iteration in interval of hypermeters values until you find the value that produce the best result. Like you can start with a set of values. Then when you see like promising some point a promising value, then you can focus on it in the later iterations. And this method is possible if you know and understand the effects of your choices on the models. And furthermore, each value has a single minimum. Like you see the promising value, then you focus it focus only focus on it, and it's possible when each parameter has a only one minimum, right? And the parameters need to be independent from each other. And intuitively, we need a more systematic approach. And then I will go to some search algorithms, because we need some kind of algorithm to make our search and our approach less biased, right? Mm. So go to the first basic algorithm. It is research. Um, it's it's a quite simple algorithm. Like you need to set a grid of hyperparameters, then train our model on each of possible combinations. Like you can see the image here. Like we have the hyperparameter x1 and x2. We have three possible value of x1 and three um, possible value of x2, x2, right? And then we conduct like 3 by 3 equal 9 combination, and we when we train our model on nine that combinations. You can see an example of a random forest classifier here. Like this model needs some hyperparameters, like the criterion of loss function, max depth, max feature, and some hyperparameter here. So you need to define. Firstly, you need to define the values of the hyperparameter first, and then you conduct the research. This is a library is supported by sklearn, and you conduct the research like it go through all the possible combination of six hyperparameters here, and finally we can call the best combination of hyperparameters. So to talk about the properties of this algorithm, firstly, it's quite simple to understand, and it's exhaustive because we need to do everything, like every possible combinations. And when using this method, we can obtain an optimal tuning very quickly. If only if we have enough processors to run the search on. If you have multi-core computers, you can use this method because it will go through all the combinations, and surely you can find the optimal one. And the disadvantage of this approach is it doesn't use information from prior experiments to select the next setting. For example, when you find this point is like the 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 optimal pair, right? And then you need to find some point near to it, right? But in this method, you don't care about the prior experiment results, and you conduct all the point equally.
All the experiment is independent results.
What?
They'll try independent on each other. They just try one by one until the end of the combination.
Yeah. And another disadvantage of this approach is applicability is quite narrow because you are limited by the the discrete searching space here, and then you can see the picture here is we have only two hyperparameters, but in case we have 10 or 20 hyperparameters, this this search is quite costly. Like you have to go through all the combinations, and so it can't work effectively with high dimensional hyperparameter space. So go to the third method. It is random search. It's quite similar to research because firstly you need to set up a grid of hyperparameters, but at the train phase you only train our model on just some random combinations. Like the first step here is also similar to the research, and when you use randomized search CV here, it's only go through some kind of some combinations. Mm, and some properties of this approach is it also simple to understand, and amazingly it worked incredibly well if we do if we do enough random samplings, right? And again, this method does deal information from prior experiments to select the next combination. And when using this method, we can't do anything except hope to be lucky when we catch the right hyperparameters. And in fact, many auto ML systems rely on this random search when they have so many hyperparameters. And by convention, we can choose we need to choose a random search when we have a high dimensional search space, like over than 16. And to go to the effective optimization method, which is Bayesian optimization method. Another name of this method is model-based method, or sequential model-based optimization method. So the reason for this name is first you also need to do some random example, random sample of our hyperparameters. Then we focus on the promising points, and so it have named the sequential. So this part is quite theory heavy. I will read the slide, and if you have some question, I will explain later. A model-based method for finding. This is a model-based method when you're modeling a function. Its name a proxy function or surrogate function, and the final aim of this modeling is to find the next promising combination. And this will give you to a reason that you will achieve better performance, and it's also support when you want fewer iteration than random search. And about this, I understand a little bit about it, and if you have question about this, the term about the definition of term I have typed here.
So what is lowest possible output value?
This like when you want when you want to focus on a reason, then you want I think we don't need some spare combination outside the optimal region, and so we need lowest possible output. I think that I don't know.
I think that's the way they describe it is like you try to find the function. So basically the optimizing is like you have the input and you have the output, but you don't have the function yet, right? So you just have the input and you run a function and you have the output. So the way they do it is they find the surrogate function, so the alternative, the true function. The first star in here, the first star here. So the surrogate function is an alternative true function. So I think the lowest possible is the closest function they can achieve to the true function?
I don't think so. I think the overall highlight is when you have when you have a set of hyperparameter, then you need to pass this. I will call it a point. When you have a point, you need to pass this point to the acquisition function, and it will output you a value that if that point is promising or unpromising, in order to minimize the proxy function here. And that is the role of acquisition function, and the way, and it's a guide to when you want to focus on the promising point, right? It like one unpromising point appear, and this function will tell you that is a red flag. Then you you don't need to focus on that point and stick to another promising point too. And the yeah. Any questions?
What lowest value is what value compared to what value? So they say the lowest value, right? Upward.
Uh, I think the lowest output value is here is the level of the level of potential. I think that. Oh, and I think we don't need to focus on the definition. It's quite hard to
Okay,
understand,
okay.
but the 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 general understand is what I said before. Like we have a boy. We need the accuracy function to estimate the potentiality of that point, and then it will guide you to the processing point. That's all. And there are some popular accuracy function is expected improvement, probability improvement, and lower confidence bound, etc. And to talk about the properties of Bayesian optimization, at first it explored randomly, and this training the surrogate function as a goal, and based on the oh, I forgot to explain you guys the surrogate function, right?
Yeah.
The surrogate function you can consider it is the loss function, but why you use this function? Because in case your true objective function is costly to compute, then you need an alternative. Then that's why we use surrogate function. It's like a substitute for the true object function when you don't need to uh, when you don't need when you don't have much um, computational capability.
I think it can explain like so. It's an optimization method. So it's like you. So it look like you training the model, right? You have the input and you have the output, and you need to find the function that fit it. But the thing here is like they don't give us the gradient information. So if you want to train it, so it really costs me, right? So instead of it, they find another way to alternative the true function. understand what I say or not? Do you guys hear me?
Yes.
Uh,
And talk about the way accuracy function work. Um, the um, the way accuracy function tell you that a point is promising or unpromising, it depends on the whole the set of points that you go through that you went through, and it computes like the mean and the the mean and the sorry. Okay. It depends on the set of previous point that you visited before. Then it compute the mean and the variance of that set of point, and then compute the level of potentiality of the next point. So, so it called the Bayesian because it based on the prior knowledge, and it used prior knowledge in order to make smarter decisions. Right? And this way will reduce the number of evaluation to reduce optimization time. And firstly, it is sample randomly the point, then it will cover the exploration feature when we do a optimization procedure, right? And when we focus on the promising point, that will cover the exploitation. So in this way, um, Bayesian optimization method balance between exploration and exploitation. Usually, it's always surrogate model is a Gaussian process. And this process performs better when the search space has a smooth and predictable response. And there are some kind of surrogate model, which is random forest, which is supported by the skop library. And another approach is TBA or a SHA or Hyperpan or many many surrogate model, and this model is usually used are usually used for complex search space. So go to the last part of my presentation. I will make some short comparison of the skop tuner and hyperop library. So so the I consider some criterion is which are easy of use, search space, search algorithm, persisting and restarting, and finally the visualization criterion. So for the first criterion is these three libraries are easy to use. Like it will have some basic steps. Like firstly, you need to define the search space, and then define the objective function, and then minimize the objective function on that defined space. And it's here is just the text And I have some picture on my note, and I will send you later. You wanna see it right now? About the imagery visualize how to use and of three libraries. I think I will send you later. So for the search space, uh, the mm, these three libraries support uh, enough kind of information like float, integer, or categoricals. And a positive point of Optional and Hyperpop is it supports you when you want to use nested search space. Nested the search space here is when when you have the oh I will show you. Can you see my screen?
Yeah.
The dog the dog's cool dogs.
Can you say with us it though?
Oh, okay, okay. Like you can see the oh, I think I will go quick fast through this part. And about the search algorithms, all three libraries or you support you the random search, the standard random search algorithm, and Bayesian optimization. And Optional also have some advanced algorithms like hyperband alpha. Um, the this algorithm is help you when you want to early stopping or something like that. I have a I have a search on these algorithms. And about the persisting and restarting, you can save the current trial and load it later when you want to continue the training process. And it also have some the function to dump and load the 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 trial object.
About that, I think most of the people in here don't have any experiment on those three libraries, so I think you should fast forward to the demonstrate. So
Okay.
somewhere will have some alternative about it.
Okay.
Because most people here just haven't seen any scene here.
I use HyperOp and I have a quite simple example here. Uh, what I do in this file is I wanted to choose I want to choose I want to choose a optimal confidence score for our CBNet model that we can obtain the highest F1 score. So the application of hyperparameter optimization is in this case is in the inference phase. Yeah, here I use the hyperop library. So the first thing I do is define a objective function. It will be the f mean score, and then I need to put the negative sign here because I want to maximize the objective function, because a hyperop is only support you the f f mean function, which means you want it means that it always want to minimize the objective function. So I put the negative sign here. This also is also a disadvantage of hyperop when it doesn't allow you to choose the direct of the search, right? And then I define the search space. In this case, I only have one hyperparameter, which is confidence score. So I have the only one line of code here. The confidence score in the interval of between 0 and 1. And then in this slide I initialize the trials mean. It means the test, or you can understand it as it's the the object that it will work all through the the combinations. And in this case, I have trained it. I have trained, and I haven't did any experiment before, so I initialize it as a an app an empty object. So you can load it from the previous trials. So you can, yeah, it support you to load the previous trial. Then the the final step here is conduct the admin function here. It will minimize the object function on the search space here, and the algorithm used is TPE. It's a kind of it's a algorithm based on Bayesian optimization, and but in this case the surrogate model is TPA. And after 100 iteration, you can dump the trials to a file, and next time you can load it and train later. So if the simplest example, I have another example here when hyperparameter optimization is when you want to train a model. The file here is on the hyperparameter tuning of PyTorch. I just follow the tutorial. This tutorial they guide you using Raytoon 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 libraries with Torch, and the model here is a convolutional neural network that um, classify the image of cipher 10, and the procedure is so the procedure here is firstly you define the config. The config here is the search space, like you have the L1 and L2 parameter here, which is the number of nodes of a linear layer in the CNN, and the learning rate and the best size. And in this tutorial they use as a algorithm to find the optimal point. And the final step is to run to go through the train procedure and pass some parameter like config to define the search space number of samples by it is the number of iterations. And the scheduler here is as a scheduler. It is a algorithm when you want early stop. So then you will have the result object here, and you can call the best result through some property like get betrayal, get betrayal config, or last result for loss function, or last result accuracy for accuracy, something like that.
Can you show the result? Yeah.
The log is quite long. It will print the because I define the the number of epoch. The number of sample is 10, so it will have 10 iterations, and for each iteration it will go through 10 epoch. So it will have a 10 by 10 equal 100 table here.
Okay.
So for the epoch, the first epoch of the minibus of 2000 images, you will have the table of a combination here, like yeah, this.
So the objective is a lot, right?
The loss of validation dataset.
Okay.
It's quite a lot because it goes through all the epochs and 10 and 10 points. I haven't investigated deeply on the log here, but But I think it's quite enough information. When I use HyperOp, it's like don't have it's only have 10 line of block through the
Yeah.
through 10 iteration. And that's all.
Yeah, so it really hard topic. I think it really useful, but I think also really hard topic to understand about the Bayesian optimization as well. And Hang also you haven't fully understand about the Bayesian yet, I think. Anyone have a question about the presentation of Hang?
Uh, this notebook, is this on your, can you send the link to this notebook?
Okay. I will send you the tutorial touch. I just
Okay. Oh, you just followed that. Okay. So they have this. Actually wanted to go through all the results, the last that you explained, uh, the configurations and all.
yeah. This is my first time too.
I put the
And
YouTube video here in case you guys want to learn about the Bayesian. I think you should see it.
yeah.
The simple video and
Yeah.